Welcome back. In the previous section, we talked about async await, how it relates to asynchronous programming, and how it relates to parallel programming, and then we dove into the compiler-generated code to see how the C# compiler takes our async task method and actually turns it into a struct under the hood. In this section today, we're actually going to create our own implementation of task. Yes, task exists in the .NET runtime. It's included. We don't have to do any of this to use async await out of the box. But to really understand how task works, how it's constructed, and some of the underlying implementation, we'll create our own implementation of task. So we'll be implementing methods like task.run, task.wait, task.continueth, all those methods we saw earlier in the previous section. Heck, we'll even make it so that we can use async await with our own custom task implementation. And by building it ourselves, we'll get hands-on experience with how these methods are constructed under the hood. Let's dive into the code and check it out. Okay, so all I've done so far is in JetBrains Writer, I've created a file new console app. So to follow along, you can go to File New or File New Solution and let JetBrains know you want to build a blank console app. And as always, the finished code is available to you with the course materials, and you're more than welcome to grab the finished code and follow along. I'll go ahead and click cancel since I've already created the console app here. The only thing I've added so far is the same food class that we created previously. So let's go ahead and fix this namespace here. There we go. So since we'll be creating task from scratch, why don't we first create a class and let's call it DomeTrainTask. This will be our custom implementation of task. And for our custom task, there's a few fields that we need to implement first. The first one we'll implement is this, using this new lock class in C# 13, new in .NET 9. The lock class is the recommended way to ensure that two different threads don't try to change the code in this class at the same time, which could lead to deadlocks and race conditions. And we'll call those out as we use the lock going forward. Also in this task is a bool called completed. And this exists to see if the task has already completed. As we saw in the previous course, a task can be completed, meaning its execution is already done and allowing us to simply return the result instead of necessarily deferring any execution. We'll also create a field that holds an exception. And again, like we saw in the previous course, if an exception is thrown inside of our task, that exception is caught inside of our try-catch block, and then is rethrown automatically for us as long as we're using the await keyword. And in this case, that exception will be stored here in this field, if there is one, until we rethrow it upon the completion of the task. Now let's go ahead and create a public Boolean called isCompleted. And normally, we would just return our field. But in this case, because we're worried about multi-threading and multiple threads checking this value, we want to ensure that we use our lock. So let's go ahead and pass in the lock we created a second ago. And the reason we use a lock here is because different threads can set the value of the isCompleted bool. And as we write that code that sets this value internally, we'll also wrap those in lock statements as well. And having both the getters and the setters wrapped in locks ensures that we don't accidentally get a false result when, say, one thread is checking the value and a different thread is changing the value. Now, the first methods I want to implement are setResult and we're going to implement setException. Now in setResult, we're going to lock all of this to ensure that only one thread can access this at a time. And the first thing we'll do is we want to see if it's already completed, because a task should never enter setResult a second time. This means something internally in our code has gone wrong. So if the task has already completed, we want to throw a new invalid operation exception, letting them know that task already completed cannot set result of a completed task. And you know what? We'll call it a DOM train task. There we go. Okay, that's where we can set completed to be true, because we know if we're setting the result of the task, that means the task is completed. And then for set exception, again, we're going to lock everything, prevent any deadlocks, which also check is completed. Because again, if the task is already completed, we shouldn't be able to set an exception on it. And here in set exception, we'll need to pass in an exception that we can assign to our field exception. Now that we've implemented set exception, set result, and is completed, let's implement task.run. So this will be a public static task. So we'll return a DOM train task, our custom implementation, and let's allow the user to pass in an action that will run on a background thread. So here, we'll create a new DOM train task. And at the end, we'll return this task. But what we want to do before we return is to queue up that action on the thread pool. So we'll call thread pool.queueUserWorkItem. And what queueUserWorkItem does is it goes out to the thread pool. It finds a thread that's available, or as IntelliSense says, it waits until a thread has become available. But of course, if there's one already available, it'll execute right away. And it'll run this block of code. So let's put in a try-catch block here, where we'll say to try and run that action. And if no exceptions are thrown, great, we'll call set result. But if an exception is thrown, we'll call set exception, and we'll make sure that we pass in that exception so that it can be rethrown when our DOM train task has completed. So let's jump back to our console app and try this out. And what I want to do is say console.writeLine, and let's just print out the current thread ID. So this will give us a ID number for the current thread. And what we'll do, we'll say DOM train task.run. And inside of this action, we'll also print out the current managed thread ID. So what we should see is we'll print out the first thread ID, and then from a background thread, we'll print out its thread ID. But if you notice, we're not awaiting this custom task yet. So this program will complete before this finishes running. So to prevent that, let's just say console.readline. And this tells our console app to wait till I tap a key on the keyboard to close the terminal. Now let's run it and see what happens. And look at this, just like we expected, we got two different IDs because this first console.writeLine ran on a different thread than our DOM train task. So we can now confirm, and we have verified that DOM train task.run will defer this code to a background thread, in this case, thread 4. Now let's jump back to our DOM train task and implement continue with.